Hello everyone. In today's video, I'm going to talk about the different things that are required if you are designing a small hardware product, something not very complicated. By complicated means something like a cell phone design or a server board design or a computer motherboard or laptop motherboard design. It's something simple that's a handheld device, maybe something simple like a blood pressure monitor, or maybe some sensor, some internet of things, something that integrates some simple Bluetooth or a Wi-Fi, and it takes some sensors, uploads some data, and something similar to that. So that's where you will start. I'm using my time as I drive to my work, where I design products for a medical device, and I have been designing the boards for I've been designing more complicated boards, including something similar to that you see in a tablet. But I also design and many times smaller boards. I have experience in the hands-on designing of this product, so I wanted to share with this video my understanding and my knowledge of the things and the products that I design. So the first thing that you will need to do is I'm talking about overall product, and when you have an overall product, there are different components of it. So the first is in overall, the most important part of that would be the hardware board itself. So you will have to have some kind of experience in understanding the existing board, and the way you gain the experience in the existing board is to learn existing designs, maybe get your hands on testing an existing boards, understand what their hardware is, open up their schematic design, and see which circuit functions in what way. So, and in to learn the hardware design itself, you need to learn some tools to be able to use this, and those two tools are schematic capture design and the layout design. So if you are typically a hardware designer, I would suggest that you should start with the schematic capture, and the layout tool will be done by another technical person who has been doing the layout design. But you should be able to read a layout. By layout means where you exactly place the component on the PCB board so that it gets to the desired function. So you need to use a lot of instruments that you use to test your electronics board. That's where you need to gain your experience. Those instruments could be simple as multimeter, but also oscilloscopes, and if it has like RF design as well, then you will need to use the spectrum analyzer or network analyzer, or more complicated and expensive tools like that. But a basic like a multimeter and the oscilloscope will get you going with most of the things. So once you know how to use those instruments, read the existing schematic, the one thing I would suggest is you should also get hands-on in learning a little bit of soldering skill, because once you are, let's say, test a board, you need to make changes in the existing board. So you should start getting your hands on the soldering skill, because if you may have access to the technicians in your lab, or if you have a place of work, but it's good to learn yourself so you can do it as on fly and do an experiment and not depend upon someone. Now those skills, they take time to develop. I mean, it's not that you start today and you get going in a week or so. So if you are already working in an organization, then it's easy to learn as you go. But what if you are not doing a work in an organization that allows you to learn those things? So what you need to, fortunately, there are things you could do on your own while you are studying in your engineering graduation, or if you are still looking for a work. What you need to do is download some free schematic capture tool. KiCad is one of the most popular tool, or it's free and open source, that you can download and draw maybe a very simple schematic, something like it can be as simple as some LEDs, resistor, maybe a photodiode, something like you sense a light and then detect it and then drive an LED or a relay, which in turn, the relay in turn could be driving something else. So this is some simple schematic you can start drawing, and if required you can do simulation is another part that you could do right on the schematic capture. By simulation I means, what if I give this input voltage and it gives out certain output voltage, and then see how it behaves in certain scenarios. So once you have done the schematic capture in KiCad, you can do the layout in KiCad also, and then generate the required file, and then take that file to a manufacturer who will build a PCB for you. And then if you are good in soldering, you can do assemble those components yourself. If not, you can have an assembly house to build that board for you, and then that assembled board, either you do it or an assembly house does it, comes to you. Then you need to power it up and then test it. Maybe buy a simple multimeter. There are less expensive oscilloscopes as well available if it's not a very high frequency. So those are the things that you could do to learn the hardware. But in addition to that, I started this topic of what are the things that's required to develop the complete product. The complete product will need few more things. For example, you will also need to learn some software. Most of the hardware products require some kind of a software to do it. So you will need to learn embedded software. By embedded software I mean some simpler stuff could have simpler software which are in C or Python. For example, you could buy an Arduino board, which is very inexpensive thing, and you can start learning the simpler stuff like glowing LED, driving relays, have sensors. For example, a gas sensor, you could be sensing a gas sensor which is like a cooking gas sensor, and see if the level triggers, then you could do some actions about it. So Arduino is a one good way to start learning software, and then in your own product you could integrate and start running that software to see how it works. It can go on more complicated if you start using Bluetooth and then app and upload the data to a server, but then it opens up a whole lot of things that you can do learning. So one thing you could do if you are preparing yourself for a job market, if you are then just be passionate about whatever product you just think about. Look around, what are the kind of the products that people needs it, and then in your mind think about it, how I could use it. Use your tools to design that product, and in the process, even if you fail, you will have a lot of learning that you could use to get a job, or maybe improve upon or learn from the mistakes and then do a next design. Another thing that you will need to, you don't need to learn all of these tools, but the purpose of this video was to let you know what are the things that you need to develop a complete product. So if you are an expert in one particular field, then you will need to take help with the persons from other fields to complete that product. So, and one of the other things that you will need to understand, or if possible know, is the mechanical design. So basically any hardware design product, or any product for that matter, needs an enclosure typically. So you will need a 3D modeling. Basically it will have one or two or maybe more pieces that will need to be mechanical pieces that will need to be put together, screw or do the things, put them together. So you design those enclosures in typically, for example, SolidWorks or similar other software products, where you can start with the cross section of the mechanical product, and then keep changing so that it gets a right look and it's a right fitting to the other parts. And once you see that it's looking good, if everything is fitting in, you get a 3D print of that product, which is an inexpensive way to verify that your design is working good. So the 3D product will typically be something like $15 or so with one piece, and then once you see that everything is fitting in, and if you see that your product has a very good volume, you could actually create a mold out of it. Then each piece will cost very little in the long run. So you need to understand about the hardware design, the electronics, the schematic, the layout, the PCB design, the testing, and then you need to learn the software of it. Then enclosure design, mechanical, putting everything, labeling. You will need to maybe involve to create an artwork of the logo that it goes in your product. And then you will need to have a documentation that will list out the product's details and so on and so forth. But then it does not end here. Once you have the product, you need to be able to prepare a strategy of how you are going to sell it in online, offline. You will need to understand about the online marketing, where you can talk about and tell people of the existence of your product, and that opens up one more area that one product will lead to you will need to actually understand this whole gamut of it. So I just pointed out this whole thing. You need to create maybe a group of people, and that's very important. To create an organization, to a group of people with whom you will be working, the salespersons, the designers, the mechanical design engineers, the software engineers, the electrical design engineers. So I just touched upon the different things, each of which, if you want to get into, will require a lot of learning. The online marketing, for example, that itself is a big field. It will take time to learn. You will learn from mistakes, what works, what does not work. You will need to create a video to let people know about the product, something like the video I am creating. I hope that this video is a little bit of helpful for you. If you can subscribe, you will know more about these products. I have some video tutorial, for example, about the electronic design in KiCad, using KiCad, which I know I understand the subject well. But there are other videos that I have put on. Some of them has to do with the online marketing and other things. So I hope you like this video. If you subscribe, you will keep getting more videos like this. Thanks for taking a look.